Good morning, everyone. We are going to look at a new test. Yes, a new test. You thought you had seen them all, but there's still a couple of monsters left. Only two monsters left, ratio and root test. Imagine this is just your generic series, right? We're back to calling them ENs. The ratio test says the following. Find the limit as n tends to infinity of the absolute value of an plus 1 over an. And it will be equal to something, let's call it L. And the ratio test says the following. If that L is less than 1, then the series converges. And I'm going to pause for a second. Oh, yeah. Okay, there we go. I don't know, maybe it's my mouse. But I click on things and I have to click on the damn thing about 5 times before it knows I've clicked on it. I don't know why that is, but it's kind of frustrating. Right, so sorry for distracting you, but just background noise. Okay, so you find the limit of this ratio, hence the name ratio test, and it'll be a number or infinity or 0. If it is less than 1, any number at all, the series converges. Technically, the series is absolutely convergent, but convergent will do. And if the value of L is bigger than 1, the series diverges. That's good news.
What if it's equal to 1?
Yeah. It's inconclusive. And that will be a choice. Inconclusive means we do not know if that series converges or not. Find some other test and do that one instead. So the kind of test you might want to do is do an integral test instead. Do a limit comparison test. Do a direct comparison test. Do a geometric series, a P series. Oh God, I'm running short of tests here. Right, do one of the other 9 tests that you could do, because this one doesn't tell you. Inconclusive is bad news. Doesn't it mean you've just spent 5 minutes of your life that you're not getting back again and you found nothing? So you don't want inconclusive, but it will happen. And in 11.7, you have to use the ratio or the root test. Now, I haven't got into what does this thing look like yet, but before I even talk about what does this thing look like yet, let's do a side issue, because you're going to be dealing with these guys a lot. And that is factorial. It looks like that guy. That's n factorial, is how you say that out loud. Factorial is a special calculation. For instance, 7 factorial means 1 times 2 times 3 times 4 times 5 times 6 times 7. And you can imagine that factorial is a pretty big number pretty quickly. I think I did a test once. I think 60 factorial will kill your calculator, your TI-84. If you try 60 factorial, the answer is so big, the calculator just keels over and dies. And if you want to know where factorial is hidden, let's do 7. I believe I hit math button and I move over to the end one and it's choice 4. Did you see that? Now, there's 7 factorial. It's already 5,000. Let's do 60 factorial and see if my memory serves me right. 60 factorial is, oh, I'm wrong. Okay, 70 factorial then. I'm going to break it eventually. There, I broke it. Somewhere between 60 and 70 factorial, the number is so big that even your TI-84 can't handle it. A bit like the American debt, right? That big, can't get it in a calculator anymore. So are we comfortable with what factorial is, right? Now, if someone says to you, could you write down n factorial? Well, you can't write it down completely, but couldn't you write it down in a kind of general way? Wouldn't that be n factorial? Now, do you notice you finish with n? But do you notice that the one before it is called n minus 1? What would the one before n minus 1 be called if I wanted to write it down? What would be this one where my finger is?
N minus 2.
N minus 2. Now, you are going to be doing in the ratio test factorials on the top of a fraction with different factorials on the bottom, and you want to be able to simplify them, cancel them down. So, for instance, n plus 1 factorial over n factorial. Imagine you wanted to simplify that. Think of this guy as 1 times 2 times 3 times n times n plus 1. Are you happy about n plus 1 factorial would look like that? And then on the bottom, 1 times 2 times 3 to n. And then there's a battle takes place where the guys on the top fight with the guys on the bottom, and there's a 1-for-1 kill. Kill, 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 kill. And at the end of the day, something comes out. So n plus 1 factorial over n factorial simplifies down to just n plus 1. You comfortable with that? Let's do 2n plus 1 factorial. No, even trickier. 2 lots of n plus 1 factorial. That's sneaky. Over 2n factorial, which is 2n plus 2 factorial over 2n factorial, right? Now let's do this guy. It goes 1 times 2 times 3. We know it's going to finish with 2n plus 2, right? What would the one to the left of it be? What would go here? Agreed? Okay, what would go here then?
2n.
Good. Now, I could keep doing that, but I'm not going to. So I'll just fill in with dots in the middle, right? Now, if I do 2n factorial, do you notice the reason why I wrote more terms on the top than I did in the bottom was, don't I want to do it in such a way that I can get a match? Right, so do you realize I needed to have a 2n here to match this one? Because when we do the cancelling,
Shouldn't those terms on the top have an addition symbol between them?
no, multiplication symbol. This is factorial we're dealing with here, Tim. Things 1 times 2 times 3 thing. It's not a series we're dealing with, it's just factorials. Now in this world, 2n plus 1, 2n plus 2 came in, which would eventually be 4n squared plus 6n plus 2. So I just want us to be aware of how you can simplify a ratio of factorials, right? A fraction where the top's got a factorial and the bottom's got a factorial. Do you feel comfortable about that process, how I've at least did these two? That's one kind of little job out the way. Next thing is I want to talk about an plus 1 and an before we go to this question. Suppose I have a sequence and it's called n squared. An is this guy. An will always be whatever this guy is. But now we need to figure out, what does an plus 1 look like in terms of n? Think substitution. Think replace the n with n plus 1. So what would the formula for an plus 1 be if I tell you an is this guy?
It would be
Parentheses n plus 1 squared.
Agreed? Right. Let's make it harder. Suppose it was an squared e to the n plus 1, right? So an would be that guy. En plus 1 would be n plus 1 squared. Be careful. What power of e would you get? Think substitution. Think replacing n with an n plus 1. What would you get?
N plus 2.
N plus 2. Now, if you want to see what that looks like, it would be n plus 1 add 1, which of course becomes n plus 2. We comfortable with that guy now? Are you, how you have two guys, one called an and the other called an plus 1. An is whatever is inside the sigma, and an plus 1 is what you get when you take this formula and replace all the n's, wherever they happen to appear, with an n plus 1 and then making it pretty. Okay. We kind of needed that background just to kind of set the story up so that we're a little bit more familiar. So let's jump right in. Here is an example, question 2, and it's sigma n equals 1 to infinity n over 8 to the n. And this is how I would set this down. I'd write down a to the n, and then I'd write down what the next guy is. And wouldn't he just be n plus 1 over 8 to the power of n plus 1? Are you happy about what I've just done? Here's the question. We're being asked to use the ratio test to see if it converges or not. First thing I do is identify who the an is and use that to figure out who an plus 1 is. Okay. Then what I would do is I would find this fella. Absolute value of an plus 1 over an. In this case, it gets really ugly because aren't both of these fractions, and we're taking a fraction and dividing it by another fraction. And so that's going to look like this. It's going to be an plus 1, which is this guy, all over an, which is this guy. Now, can you imagine algebraically how ugly that is to deal with? So let me tell you a little trick that we tend to do. I tend to not write this line. What I tend to do instead is use a nice property. If you take the top fraction and you divide it by a bottom fraction, can't you change it into the top fraction multiplied by the reciprocal of the bottom fraction? In other words, this guy here is the same thing as top guy multiplied by the reciprocal of the bottom guy. Does that make sense? Top fraction times reciprocal of the bottom. 9 times out of 10, you're going to find out that these are fractions, so that kind of helps. Technically speaking, there's an absolute value around it. Could I have omitted the absolute value in this question? Right. Isn't the absolute value only going to be really relevant if the numbers had negatives in them, like in alt and n minus 1 to the n? So if you skip it, it's not a big deal. But we'll keep it in because it's here now. Now, once you've done step 1, identify an and an plus thingy. Step 2, write it down. Step 3 is coming up. if things have worked out correctly and you haven't screwed up in any real way, shouldn't you be able to cancel some stuff at least in less than a superficial way? Can that 8 to the n cancel out some of the 8 to the n plus 1? Can 8 to the power of n on the top cancel out some of the 8 to the n plus 1 on the bottom?
If you factor an 8 out of the bottom, you can cancel it out completely.
And so what you're going to be left with is an 8 on the bottom. Agreed? And on the top, you've still got these two guys. So you don't need this line, but I'm just going to write it again. Aren't you looking at this fella now? And I've decided to just do away with the absolute values. They're not necessary and they're just getting in the way. We're getting there. I know the answer to this limit. What is it?
1/8.
So couldn't you do L'Hopital on it? Or divide top and bottom by n on it? I'm just cutting out some lines for speed. You got an 8th. And back to our test then. This guy is actually who L is, right? The limit. Is this guy less than 1? Yes. Conclusion. Series converges. So that guy converges. Now, if I went through that same process, but it wasn't 1/8, let's say it was 9/8 for argument's sake, wouldn't the answer be it's greater than 1? Conclusion, whatever that series happened to be, would diverge. Suppose I got the answer equals 1. Conclusion, bad news, inconclusive, we don't know. But that's an acceptable answer in these questions. Any questions about that? Try another one. It takes 2 or 3 to get the swing of these things. So let's try this one. This is version equation 3. And it's a negative 8 to the n over n squared. So an is negative 8 to the n over n squared. And an plus 1 is negative 8 to the n plus 1 over n plus 1 squared. Pretty straightforward so far. Now we're going to do the limit as n tends to infinity of the ratio, which is that guy. That's going to become the limit as n tends to infinity. an plus 1, which is this guy, technically divided by this guy, but that's the same thing as multiplying by its reciprocal. I'll pause. Are we good up to this point? Are you happy about where things came from and what they ended up looking like? Right, now the cancelling is always the fun part. You have to be on the lookout for what can cancel and what you have to just leave alone for a little while. Okay, can you see anything cancelling with anything in this expression here?
We could factor out an 8 again.
Right, and if you did that, wouldn't there be a negative 8 left on the top? And on the bottom, won't there be an n plus 1 squared? Which I am going to multiply out to go like that. Now, you notice I've kept the absolute value right now. And the main reason I've kept it is, do you see this guy here is negative 8? Okay. If you stick an absolute value around that, won't it basically destroy the negative? Great. So what will the thing look like? You probably don't need this line, but I'm putting it in anyway. Would you agree that the line above and this guy here are the same? Absolute values only do one thing. They make things positive, right? They don't change numerical values. They just make them positive. Okay, what's that guy going to be? What's the limit of that guy?
8.
Let's do L'Hopital.
Yeah, do L'Hopital on it, divide total bond by n squared, but you know there's some lines in there, I'm just not putting everything in, right? What's conclusion going to be?
Averages.
Yep. Because it's bigger than 1. I mean, it's not as quick or as easy as a P-series test, but it's a lot better than an integral test, isn't it? So, you know, it's kind of in the middle kind of amount of work. Right, let's do one with the factorial in it. Okay.
Is there any instance that we can't use this?
Yes, tons of them. All the ones that you get inconclusive from. But you won't know until you've done the question that it's inconclusive. So yeah, I mean, I wish, you know, like all the other tests, I wish it worked for everything, because then wouldn't there only be one test? And we'd just use it for every situation. So unfortunately, no. No particular change here. Have you noticed that the counting variables k instead of n? But that really isn't an issue. I hope it isn't anyway. So I'm going to call AK this fella. So AK plus 1 is this fella. We're comfortable with that? Instead of EN and EN plus 1, it's AK and AK plus 1. So I'll now do the limit of k tends to infinity of AK plus 1 over AK. That's going to be the limit as k tends to infinity of this fella, the AK plus 1 guy, times the reciprocal of the other guy. Now, remember we did at the start of today a k factorial and a k plus 1 factorial, you know, combinations of those things. Won't the k factorial kill off most of k plus 1 factorial? And while we're at it, won't the 7s kill each other off as well? Right. So what's going to be left behind? If k factorial kills off most of the k plus 1 factorial, what's going to be left on the bottom?
A single K.
Almost.
Should be k
K
plus
plus
1.
1.
K plus 1. Agreed? 1 to k, 1 to k, and an extra term left over. The extra term left over in this case happens to be in the bottom, right? Maybe the next time it'll be in the top. Would you agree you can brute force this and get 0? And isn't 0 definitely less than 1, so it converges? Cool. Try an ugly one. Oh God, I'm going to try my own. How about this one? I'm writing down the question, how to do it first. Suppose we did this one, and I am picking this one because it's got as many things in it as you could possibly want or not want. It's got that guy. It's got that guy. It's got that guy. And it's got that guy. So I'm pretty much putting in one question the major bits and pieces that you tend to get. Most of the questions you get won't have all of these. It might have like those three, or those three, or those three, or those three. It won't have everything. This one has got all of the bits in it, and I like this question because I just made it up. And the reason I like it is if you can do this one, you can do all of them, essentially. So AN is this guy, this guy, this guy, times, and we'll put a little dot there, times this guy. And so EN plus 1 will be that guy, that guy, that guy, and that guy. Put a little dot. Are you happy about the EN plus 1?
And you simplify the top,
Could I
the
simplify?
numerator, by putting like -2 to the n plus 1.
Yeah, you could. I'm not going to, but you could. It wouldn't be a bad thing to do. And so we're going to do the limit, the ratio test essentially, which is this guy. And that's going to be the limit as n tends to infinity of this fella, untouched, times this guy upside down. When you do these questions, and in particular when you do the cancelling, it's good to know what you can cancel and what you have to just leave alone for a little while. Okay, would you agree that this -1 to the power of n plus 1 will cancel out with the -1 to the n? What gets left over in that little battle? Cancel out.
-1
Okay, top or bottom?
on the top.
Right. So think of it as a little battle, and the guy that won was on the top, right? Okay, we have a 2 to the n plus 1 and a 2 to the n. Who's going to win? The top, agreed? And so when you cancel these two guys out, 2 to the n plus 1, cancelling out 2 to the n, what's left? Because it's going to be in the top, isn't it?
2.
2. N squared and n plus 1 squared. Can we just tag them at the end? And while I'm at it, just multiply the n plus 1 squared out. So I'm not going to cancel anything. I'm just, leaving them alone for the time being. Okay, one last guy. N factorial on the top, n plus 1 factorial on the bottom. They cancel out. They had a big fight. Top or bottom? Who's going to win?
Bottom. and it should
What's
be
left in the bottom then?
N.
Nope.
Sure.
Imagine n factorial, n plus 1 factorial, 1, 2, all the way to the n, 1, 2, all the way to the n, and an n plus 1. Cancel, cancel, cancel. Can you see what's left over?
N plus 1.
N plus 1. Right. Let's take care of some things. Can I get rid of that by just taking the absolute value of it and making it go away? So what that leaves me with is the limit as n tends to infinity of 2n squared. On the bottom, I've got this guy and this guy. So all I'm going to do is FOIL the whole thing out. So it's going to be n cubed plus 3n squared plus 3n plus 1. Okay. Don't need absolute values anymore. We've taken care of that. That's why they're not there. What's that going to be? What's the limit of that fraction going to become?
Zero.
Yeah. Divide top and bottom by n squared. Do L'Hopital 2 times, and you'll get 0. And that is definitely less than 1. So it converges. Do you like the ratio test? I mean, it's got a lot of stuff in it, but at least it has a flow to it, doesn't it? And don't the cancelling tend to be the same kind of cancelling? Sometimes it's the top that wins, sometimes it's the bottom that wins. You know, factorial, okay, you might take a few more shots before you're comfortable with cancelling factorials, but once you get into the swing of them, there is a kind of logic to them as well. And it comes out. And occasionally you're going to get equals 1, but in your homework, there will be a circle that says convergent, divergent, or inconclusive. And when that happens, you pick the inconclusive, right? Have you noticed that we haven't even told you what these guys add up to? All we've told you is that they converge. And that's true. We don't tend to. They could add up to anything, right? And there's no one way of telling. Well, there is one way of telling. I'll take that back. This is how an engineer would solve this problem. Mathematician tells them he converges because, you know, they're not too bright and they can't do math, unlike us. So we tell them it converges. And then the engineer says, but I don't want to know it converges. I want to know what it adds up to. Right? This thing ends up being the total amount of force acting on something. I want to know how big that force is because my bridge might fall down if I don't put in enough steel. How do you think an engineer would come out with an approximate answer to what that adds up to? And keep it simple. What would he do?
Plug in like 1,000.
Yeah, wouldn't he actually, because he's lazy, go to your computer and tell it to add up 1,000? And would you agree that if something converges, probably way before 1,000 terms, wouldn't you get a number that's darn close to the right answer? In many cases, the first 20 numbers is enough. Right, just add up the first 20, you're probably good to 3 decimal places. And isn't that tolerance? Because engineers always do things in terms of tolerance. You know, nothing is perfect in engineering, isn't it? It's plus or minus. Time for me to tell you a joke then. A mathematician, an engineer, and a lawyer go for a job. And mathematician goes into the office and there's only one interviewer there and he sits down and the interviewer says, just one question, what's 1 + 1? Mathematician says it's 2. And the guy looks at him and says, are you sure? He says, of course it's 2. It's always been 2. It's 2. He says, okay, great. Interview was over. So the engineer goes in and gets the same question, what's 1 + 1? But being an engineer, he's not too bright, so he has to think for a while. But eventually he says it's 2. He used his fingers, but he got there. And the guy says, are you sure? And he thinks a bit longer and he says, well, just to be absolutely certain, it's 2 ± 1, because that's how engineers work. And that was his interview over. So the lawyer goes in, gets the same question, what's 1 + 1? The lawyer doesn't say a word, gets out of his seat, closes the office door, goes over to the shades, pulls them down, walks over to the guy and whispers into his ear, what do you want it to be equal to? After all that hard work, I got one nod and one smile. Come on, that's a good joke. Unless some of you have lawyers as parents, in which case I'm probably in trouble now. Are we good? Right, let's move on. Let's pick a question. What question should I pick? Okay, Let's do 6. It's another k equals version. Now, AK is 7k e to the negative k. I'm not arguing that's what it is. But I suggest that you write it like that. Why do you think I want to turn it into a fraction rather than leave it as a negative k power? What do you think my thinking behind why I'm doing it that way is?
Because when you have to times them, you can just flip them around later.
Yeah. Can you imagine trying to, do it the other way? You might end up doing it the wrong way or something. So I try to avoid my opportunities for screwing up. Are you happy about that's what a to the k plus 1 would look like then? And now we can do the ratio test. So we're going to find the limit as k tends to infinity of a to the k plus 1 over a to the k. And that's going to be the limit as k tends to infinity of this guy times the upside down version of this guy. Did you notice that in this question, I decided not to put the absolute value in? I could have, it wouldn't have made any difference, but I chose not to. Why can I get away with it? I mean, it's totally okay to do that. There's nothing wrong with it. If you did it, you're right. But why did I not bother?
Because it's not going to be.
Yeah, everything's positive, agreed? So you don't need an absolute value if everybody's positive. Okay, time for death. There's a battle going on. Tell me somebody that's going to kill somebody and what's left.
Seven kills 7.
Tell me another battle.
E to the k kills e to the k and leaves behind an e on the bottom.
Have you noticed that Scottish mathematicians, or at least me, are quite violent in the way that we describe algebra? Right, that things get killed by other things. It's quite a good analogy, in my brain, at least. It's quite a good analogy. Now, we're left with a rather weird looking fraction. K plus 1 on the top, EK on the bottom. You know, E is just a number. It's like 2.7K, right? That's all it is. Anybody want to tell me what that is equal to, that limit?
1 over E.
Okay. I would probably do L'Hopital on it when you get 1 on the top and E on the bottom and you're good to go. Now decision time. Is 1 over E bigger than or less than or equal to 1? Well, it's not equal to 1, okay. Is it bigger than or less than 1?
Less than.
Conclusion.
The series converges.
Cool. Is this process begin to have a flow to it? Right? You got your guy, you got your AK or AN, whatever letter they decide to use on you. Do your little ratio thing, cancel everybody out, see who's left alive, find that limit, bingo.
Would it be wrong if we had a problem that had like a K or an N or whatever, and we just rewrote it to have an N?
So you went, if I think what you're saying is, could I take this question, just say N equals 1 to infinity, make everybody N? Is that what you're saying?
Yes.
Yeah. Mathematically, aren't they totally equivalent? So you're answering the question. The letter that of choice, isn't that cosmetic? I couldn't have called it M equals 1 to infinity, 7m e to the minus m. Wouldn't that be exactly the same question, essentially? Cosmetic, right? The variable letter, the counting variable is unimportant. So yeah, that would be fine. Ooh, that's a cool looking question. I don't Oh, that's a good one. Darn it, which one of it? I don't have time for both. Okay, I'm doing 7. This is our last question for today. Tomorrow, I've got a really cool question to show you. Oh, it's a good one. But to finish, there's a factorial. We'll do that guy. So it's an is n factorial over 100 to the power of n. And a plus 1 then is n plus 1 factorial over 100 to the power of n plus 1. So the ratio test is this fella. The an plus 1 guy, untouched, and turn the other guy upside down. Would you agree I don't really need absolute values in this question, so I'm going to skip them out in a minute. What is the, right, what's going to happen in this battle?
You'll have
Somebody
100 left over in the bottom.
Agreed. There's our factorial cancelling again, right? Hopefully we're getting better at these guys.
That was actually the 100 to the power of n canceling.
Yeah, that is correct. So what happens when you cancel these two?
You're left with n plus 1 on the top.
Correct. And if you brute force that, would you agree it's infinite? So it diverges. Well, isn't infinity bigger than 1? So it diverges. I haven't tried to prove the ratio test, nor will I. But can I tell you that the ratio test works because they look at the idea of a geometric series. And in a geometric series, isn't the common ratio r less than 1? Remember? Well, can you think of this as being like the long-term version of the common ratio? And as long as the long-term version is less than 1, the terms disappear, right, mean getting smaller quickly enough for the series to converge. I know that's not a very valid proof, but does it give you a feeling that there's a reason why it is what it is? Oh, I am getting good. 949. So last name, space, first name, and bye-bye. Of course, I'll hang about if there's any questions.
Can we go over the end of the problem that was the medley of all the different components?
I can do that. You want to see the working for it?
Yeah.
Here it is. So is there any point, you know, from this line to that line that you want me to talk about? I can do that too.
So when the line where you wrote divide by n squared, what do you do after that? Because I tried doing it and I got kind of stuck at L'Hopital's.
Okay. Right here. Okay. So let's do this guy, and we could do it 2 different ways, and both ways will tell me the limit is 0 because that's what the limit is. So I'll write the guy again over here. And do you want me to do it with L'Hopital, or do you want me to do it by dividing the top and bottom by n squared? What method do you want me to show you? Do you mind?
How about divide by n squared?
Okay, so if you divide the top and bottom by n squared, it turns into the limit as n tends to infinity. Divide that by n squared, you get 2. Divide this by n squared, the next term by n squared, the next term by n squared, and the next term by n squared, you get that. And then when you do brute force, you get infinity. You get 3. 3 over infinity is 0. 1 over infinity is 0. 2 over infinity plus 3 is still infinite. 2 over infinity gets me 0, and that's the limit is 0.
Oh, I get it. Okay, because I thought you said divide by n squared and then do L'Hopital's twice.
No, or do L'Hopital's twice.
Okay.
Now, if you want to see it, since you're here, I might as well do it. If you want to see what L'Hopital would give you in this question, takes more time to write it than it actually does to think it through. If you did L'Hopital once, you'd get 4n on the top, and you get 3n squared plus 6n plus 3 in the bottom, but that would still give you an indeterminate form, infinity over infinity. So you do L'Hopital a second time, and you get 4 on the top, and this guy gets you 6n plus 6, and then you can brute force it and get the limit of 0.
Okay, thank you.
Okay?
Yeah, I had another question, but if
No, go
someone
for it.
else-
No, well, anybody else got a question? Okay, it looks like you've got the floor then, Rosie. What you got?
Okay, it's from 11.4. 11.4, number 8.
Let me wind back. 11.4, question 8.
I could read you my version.
Oh, good. Tell me that.
So the limit from k equals 1 to infinity of the cube
Limit
root
k equals
of
1 to
k.
infinity. You mean sigma k equals 1 to infinity?
Yeah, that's what I
Okay.
meant.
Okay. K equals 1 to infinity of?
Cube root of k over
Okay.
the square root of k cubed plus 8k plus 4.
Well, I'm going to do this by comparing this guy to a P series. So let's see what the P series would look like. The cube root of k is k to the 1/3. Agreed?
Yes.
When you talk about this bottom one, the only term that really is important is the k cubed, because that's much bigger than any of the other two terms. So that's essentially the square root of k cubed. And the square root of k cubed is k to the 3/2. So this guy behaves, right, like this fella. Now, a little bit messy, so let's make it a single power of k. And 3/2 take away a third. 3.
It's
Oh.
7/6.
Oh, thank you. Now, that's a P series, isn't it? And
Yes.
the P is 7/6, and 7/6 is bigger than 1. So doesn't that mean it converges?
Yeah, and then so I did an over bn, and I got to.
Oh, okay, so now we're going to do the limit as n tends to infinity of an, which is this ugly guy, over bn. If I do bn, can I just take this guy and turn him upside down? So basically, that guy. An divided by bn, an multiplied by reciprocal of bn. So if you turn it upside down, are you okay with that, or do you want to see the line where that came from?
I'm okay with that.
Okay, so now I'm going to, evidently my n's have turned into k's. Here we go. There we go. That's a third, and that's 7/6. So if you take 1/3 and you add it to 7/6, you get k to the 3/2 all over k cubed plus 8k plus 4. So with me?
Yeah.
Now I'm going to call that guy the cube root, the square root, I should say, of k cubed over the square root of k cubed plus 8k plus 4. This isn't the only way of doing it, it's just the way my brain is working. And now I've got that since they're the same thing, can't I just do a single square root that looks like that? Now, when you got the square root of somebody, can't you do the limit of the inside and then take the square root later? What's the limit of k cubed over k cubed plus 8k plus 1 eventually?
1.
And so wouldn't the answer be the square root of 1, which is 1, and you have got what you needed. According to the ratio test, don't you just need to prove that the limit is a number that's not 0 or infinity? And we already know that the guy we're comparing against converges, and since the limit is a number, our guy converges.
Okay. Thank you.
A really ugly looking radical, that one, wasn't it?